Today's lesson is on metric to metric conversion and metric to the US system or English system, and vice versa. So this is the metric system, something that you probably have been familiar with. Many times there is a mnemonic device for this central region. The kilometer, or the prefix is kilo, hecto, deca, the base unit, which can be anything from meter, liter, gram, depending on what you are measuring, and then prefixes of deci, centi, and milli. Those are probably the most recognizable. When students are doing these, primarily converting, what you're doing is you're saying, I have this number in one prefix, what does that equal in another? So the two numbers that you have, in essence, are going to be the same, but the coefficient in front of it will vary because now you are supplying a different prefix, which is going to signify the size of that as well. The 3 to the left of base and 3 to the right of base are all 10 times the size of each other. So what that says is if I have a unit in a base value of a meter and I want to convert that into something that is a decimeter is 10 times smaller. So if I have 1 meter compared to 1 decimeter, those are not equivalent distances. So what was the comparison? Well, 1 meter is going to be 10 times larger than 1 decimeter. Or you could say it the other way. This is why it's a little confusing, is because you could say that the perspective is the deci and saying that 1 decimeter is 10 times smaller than 1 meter. But in this, we're going to try and convert to say, well, if I have 1 meter, what is that equivalent to if I convert it into a decimeter? You have been taught most often to do like this little bunny hop situation where you're going from the base unit over 1, so I would move the decimal place 1 place to the right. So if I have 1 meter and I want to say, what is that in deci? The decimal place is assumed to be after the 1 in the number 1. So therefore, if I move it 1 place to the right, now I've produced an extra 0, which says there's 10. So that's a way that students have done it in the past. Does it work? Sure. Or you wouldn't have been taught like that. Is it the most effective or easiest way? Probably not. The thing that you have to recognize is that everything is a power of 10. And if you kind of associate the powers of 10, notice that everything that is somewhat larger, all these numbers to the left means that these prefixes are larger prefixes. So 1 decameter is 10 times larger than 1 meter. So if you can imagine what 1 meter looks like, think of a meter stick. 1 decameter is 10 times that. So it would take 10 meter sticks to be equal to 1 decameter. So the things to the right are smaller, and I think these prefixes probably show you that they're smaller. So micro is a very small prefix. These central ones, again, are easy. But what starts to happen are when students try and convert to anything out here, the bunny hop method is a little more tricky because they don't continue at 10 times their value. The difference between a milli and a micro is 1,000 times. See, the difference in powers of 10 is 3. If you have a difference between 10 to the negative third and 10 to the negative sixth, that's a power of 10 to the third. So it's 1,000 times the size between these two lines. So I did put a little gap there, but that's something that some students don't recognize immediately and kind of just say, how far away is it? And they just keep the bunny hop method and they'll be off because they continue with the 10 times the difference. So the way that I do this when I'm converting from metric to metric is I have these memorized. This is something I don't have to reproduce this number line every single time I try and do a metric to metric. So I'm going to do some problems. I'm going to kind of walk away because my board is over here. And I will show you how the easy way, I think, to convert from metric to metric. So you have to understand these. The prefixes are down below, so you can spend the time to memorize this stuff. The things that stand out, this prefix right here is what's called a mu. It's I think a Greek letter because the prefix for the letter M has been used too many times. So this is a mu, so recognize that. The other thing is, between deci and deca, they both start with the letter D, and they don't capitalize it, but deci is always given the 1-letter prefix. Deca is most often I see DC, I see DA, but if you see 2 letters before the base unit, in all these cases I did meter. All these could be L's for liter or G for gram, but we do a lot of length measurements in this class, so I picked that specific base unit. Out here, not often do you measure in this, but in just the practice of converting, recognize that prefixes are capitalized, a capital M and a capital G. So what I'm going to do is I have to recognize and know these prefixes with the positive or negative in front of it as well. So it's not just the number, is it a negative or positive exponent? So if I were to ask to convert between, if I make like a number up, 7.17, and I am pretending that that is a hectometer. And I say, well, what does that equal if I don't want it in a hectometer unit, if I would rather have that in a centimeter unit? How would I do that? You can draw the number line, which is going to take you time. But if I remember from my previous thing that I've memorized that the unit for a hectometer is 10 to the positive second. Centi is 10 to the negative second. And sometimes I don't even put the 10, I'll just put the prefix, or the exponent value. Because at this point, all I'm going to do is I'm going to subtract just the exponents. So I'm going to look at this exponent, the one that I start with, and I'm going to subtract it from the exponent where I want to go. So in that case, I'll do it very simply. It is 2 minus, and it's important to keep that minus still with that centimeter unit. I can't just get rid of it. So what does that equate to mathematically? That is a positive 4. So what's important about that value is saying that the positive says that I have to multiply my original number. I'm not going to divide. If it was a negative number, I'll do an example like that in a little bit. The negative would signify that I divide. So what I'm going to do is I'm going to take my 7.17 and I'm going to multiply it. That's why the positive value, that's what that says. That's just this indicator. If it comes out to be a positive number, multiply, and I multiply by 10 to whatever this number is. All right? So this is what I would multiply to get to my centimeter value. So that will, in turn, be 71700. All right? So 71,700 centimeters. That's the mathematical operation. And sometimes you're asked how you got there. It's not just what the answer is. So it's a multiplication process. So what this says, centimeters are in the smaller value than hectometers. So from 7.17, if I multiply that by 10 to the 4th, that's how many centimeters would be in the same equivalent in hectometers. That's one example. So let me do another one. We're reverse. So let's do something like millimeters to, so DKM, that's the deca. So if I make up another value over here, so 2,310 millimeters. So millimeters, I remember that it's a -3, so that would be 10 to the -3rd. Deca is 10 to the +1st, all right? So that's the number I really care about. It's a positive value. So what do I do? -3 minus a +1, so I don't have to do anything kind of special there in math. What does that equal? -4. All right? So here's what we have to do. I'm going to mathematically, because this is a negative, my end result when I subtracted what I was given to where I want to go, I got a negative value. So that means I'm going to divide by a power of 10. And what power of 10 do I divide by? Whatever this value is. All right? Students will often do the same symbol that's in front of that. The negative sign only says I divide. So as soon as I got my division, I now figured out that I don't have to use that anymore. So my power of 10 is always a positive value. Don't put a -4. Don't divide by a -4, or you'll be doing too many orders of operation there. So what you do is 2,310 divided by, I divide because the negative, and I divide it by 10 to the 4th because that's the value that I got right here, which is 4. So with that, I would get the answer, if I put that in your calculator, you're going to get 0.2310, and the 0 is kind of arbitrary at this point because it's in the decimal value, decameter. So those are two examples. If you have any questions as to why, but you really have to just focus on, all I need to do is memorize what are the powers of 10, if they're positive or negative. I take my power of 10 unit that I start with, which in this case was hecto or 2, subtract it. This is always a subtraction. I always subtract it to where I'm going, which in this case was a -2 prefix. I got a positive value. Positive says I multiply by a power of 10. What power of 10? 4, because that's the value I got when I subtracted the 2. In the other case, -3, +1. So -3 minus, this technically is a positive value. All right, I don't really do that in math. But that would come out to be equivalent to a -4. Negative just says to divide by a power of 10 raised to the 4th, because that's the number I got. If it was -5, I would divide by 10 to the 5th. Then I would do that in the calculator, or you can move the decimal, and you get that final answer. So those are two examples that you would be kind of asked to do on a test. You can do one that is beyond the middle 6, I would say. So if we did one that was a little trickier, that students would struggle with if they do just a number line. If I'm saying I want to go from kilometers out to micrometer, and if I said that I have 0.00061 kilometers, what is that micrometers? Kilometer, recall, is 10 to the 3rd, and again, it's a positive, and you might want to even just put the positive value there just so that it doesn't get in the beginning, I would probably even put positives. I know that you don't often do that, but it's just something to keep track of. Micro is -6. So what do? I take that +3, subtract it from a -6. That's going to be a +9. So that says I'm going to take 0.00061 and multiply it by a 10 to the power of 9. So that just means, in scientific notation, which is what this is going to do, is I'm going to move this decimal, because of the multiplication I'm going right, I'm going to multiply it by, move it 9 times. So that would probably be 1, 2, 3, 4, 5. So then I have 4 more. So it would be 6, 1, 1, 2, 3, 4. Okay? So that's just another way when you get larger numbers, when you're out there in the micro and nano or mega and giga. So that's how to do metric to metric. If you have any questions, please let me know.